the purpose of showing work for solving problems in first grade. It helps us understand how they solve a problem. If a mistake is made, we're able to know why and how to help the student. It gives students a visual prompt for explaining their thinking, and it leads to fact fluency and builds a stronger understanding over time. There are many ways to show work that highlight solution strategies. Students can draw pictures or write equations that show their thinking. Let's use this as our story example. Sam has a collection of 14 shells. 9 are clam shells and the rest are snail shells. How many snail shells does Sam have in his collection? So first I will show some student representations. Some possible student representations. Some students might draw all 14 of Sam's shells, count the 9 and cross them off, and circle the remaining shells. Labels are helpful in clarifying students' thinking. Other students might draw this as an unknown add-end problem. So they will draw the 9 circles to represent the 9 clam shells and count on until they reach the number 14. Other students might make the same picture but group 1 with the 9 to make it 10 and continue counting on. So this student's picture is similar to the one above but demonstrates that they use the make a 10 strategy. Some students might solve using equations. So some students might write an equation with an unknown add-end, starting with 9 to represent the 9 clam shells, and draw circles above until they count down to 14. Other students might still use an equation with an unknown add-end, but instead of counting on, they draw lines below the unknown and make a 10. So they know that 9 goes with 1 to make 10, and they know that 10 plus 4 is 14. So when they add the two partners together, they get their total. Some students use math mountains to make sense of a word problem. They understand that the total from the story goes at the top and the partners go at the bottom. Some students can show their thinking by drawing circles down the side of the unknown to get their answer. Okay, Grant, I want you to solve this problem for me. Sam has a collection of 14 shells. 9 are clam shells and the rest are snail shells. How many snail shells does Sam have in his collection?
I'm drawing 9 shells because that's the partner we know, and then I'm going to count on to 14. 10, 11, 12, 13, 14. And I'm labeling.
Very nice. I like how you labeled your answer. Grant, could you show your work another way? Or represent your thinking in another way? Why did you circle that?
Because that makes a 10. I'm labeling my answer.
Very nice job. Sam has a collection of 14 shells. 9 are clam shells and the rest are snail shells. How many snail shells does Sam have? Can you explain how you got this equation?
Well, I know that there are 9 clam shells, but I don't know how many snail shells there are, and I know there are 14 in all.
Okay. Can you tell what you're doing now?
Right now, I'm finding partners to make up 10, and I know that 9 and 1 make 10. And I know that 10 plus 4 equals 14. And I know that 1 plus 4 equals 5. So I'm going to draw 5 in here. And so my new equation is 10 plus 4 equals 14.
And so how many snail shells does Sam have in his collection?
5.
Excellent job. Could you show your work using a different way?
I can.
So Sam has a collection of 14 shells, 9 are clam shells, and the rest are snail shells. How many snail shells does Sam have? Okay, so it's the same equation as last time, right?
Yep.
Okay.
9, 10, 11, 12, 13, 14.
What are you doing there, Lily?
I count it on and I draw 1, 2, 3, 4, 5 dots. So the answer must be 5.
Nice job labeling your answer. Good work.